Hello students, today I brought for you one interesting and important topic that is hybridization. So how to identify the hybridization in a given organic molecules. Okay, now hybridization majorly depends on number of bond pairs plus number of lone pair of electrons. Lone pair of electrons. So identify either bond pair of electrons or lone pair of electrons. But in this cases, so we will explain only based on the bond pairs and another one lone pair of electrons also. Then the first example is how to identify that. If a number of bond pairs including number of lone pair of electrons equal to 2, so that one represents sp hybridization. If the sum or the bond pairs and lone pair of electrons equal to 3, that is sp2 hybridized molecule. If it is 4, the hybridization is sp3. So these are the conditions. The sum of bond pairs and lone pairs are only bond pairs. So based on that conditions. Now we will discuss one example here. The first example is ethane molecule. Ethane. In this ethane molecule, two carbon atoms are present here. The two carbon atoms bonded with each other. At the same time, the two carbon atoms bonded with the hydrogens also. In this given molecule, how to identify the hybridization? So based on the number of bond pairs, here first identify the bond pairs means carbon hydrogen. This is the one bond. Again one more, it is bond pair. It is also bond pair means electrons only, bonded electrons. Here also between the carbon totally 4. So 4 represents it is sp3 hybridized carbon. Again the adjacent carbon it is also has 1, 2, 3, it is 4. So completely this molecule is sp3 hybridized molecule. sp3 hybridized molecule. Then if you observe another example, same as like CH3, CH2, CH3 molecule. In this, my carbon has here 3 hydrogens means 3 bond pairs plus 1 is a bond with carbon. Totally 4. So again here 4 bond pairs. So 4 bond pairs again it is sp3 hybridized carbon atom. Next this carbon 2 hydrogens 2 bond pairs, again 2 bonds with adjacent. So again totally 4 bond pairs. So 4 bond pairs, it is also sp3 hybridized carbon. And next in this third one again 3 bond pairs plus this is another bond pair with carbon. Now 4 bond pairs here also present. Now this carbon also sp3 hybridized carbon. So overall this complete molecule sp3 hybridized molecule. Okay, this one is sp3 hybridized molecule. So in this sp3 hybridized molecule, so next another example, CH3, CH double bond CH2. So this molecule propene. The name of this molecule is called propene molecule. Propene. How to expand this molecule? So the expansion structure. One carbon has 3 hydrogen atoms. 3 hydrogen atoms. Next, one hydrogen between double bond C H H. Now these are the bonds attached to the central atom carbon atoms. Now central atom carbon atom has how many sigma bonds? 1, 2, 3, 4. So this one is a sp3 hybridized carbon atom. Then coming to this carbon, already it is a 1 sigma. It is also sigma. It is sigma. If more than one bond is present, one is sigma, another one is the pi bond. Now consider here totally the surrounding bonds only 3. So 3 means this carbon is the sp2 hybridized carbon. Now coming to this last one, this carbon atom, 1 sigma, here also sigma, sigma, totally 3. So this carbon also sp2 hybridized. So now this total molecule is a combination of sp3, sp2 hybridized compound. Okay, ma, sp3, sp2 combination only. Then another one molecule we'll discuss, ma, CH3, CH2, CH double bond, CH, CH2, C triple bond, CH. So like this one molecule is given. So identify in this number of carbon atoms. So number of carbon atoms also more. 1, 2, 3, 4, 5, 6, 7 carbon atoms. Now first carbon identify in this. Total 3 bond plus 1 totally 4 means sp3. Next this carbon same 2 hydrogens 2 bonds with 2 carbons sp3. Next this carbon here it is a 1 sigma, 1 pi bond, 1 hydrogen and this bond totally 3. So this one is the sp2 hybridized carbon. Next adjacent also same only, it is looks like same carbon. So this one also sp2 hybridized carbon. Then this middle carbon here 2 hydrogens adjacent to 2 bonds totally 4 bond pairs. So this one sp3 hybridized carbon. Then this carbon it is a sigma bond. Here also 1 sigma. The remaining 2 pi bonds only. So completely here this one 2 bond pairs only, 2 bond pairs. So it represents sp hybridized. Again here also this carbon is sp hybridized. Now identify these given conditions, sp3, sp2, sp type of central atoms present, carbon atoms. So these hybrid carbon atoms. So sometimes they will ask the type of carbon atoms in this based on the numbering. 1, 2, 3, 4, 5, 6, 7. So in this given compound, so the hybridization present in the following molecule at C2 and C3 carbon atoms, the hybridization. At C2, it is the second carbon. What is the hybridization? Sp. Next, this carbon is the third carbon. The hybridization is sp3. So what is the combination? Sp3 hybridized carbon atoms present at second and third position. Second and third position. Sometimes they will ask like this also. At C3, C4 carbon atoms. At C3, C4. C3 carbon is a sp3 again. So this one is sp3 combination. The adjacent carbon is a 4. It is a sp2 hybridized. So this combination is sp3, sp2 hybridized combination. So these kind of combinations also very, very important. So definitely they will ask any one example. Identify the types of hybridized carbon atoms present in a given molecule or at a given particular carbon at C2, C3 or C3, C4, C5, C6 or C1, C2. So like that kind of examples also they will ask in your exams. Okay, this one hybridization present in given saturated and unsaturated molecules. Saturated and unsaturated molecule. Some another important example here, alene molecule, alene. Okay, alene molecule here. So that alene molecule majorly it exists like this. CH2 double bond C double bond CH2. This is the alene molecule. So for this kind of alene molecules, so how to write that hybrid carbon atoms? That is also important. That hybrid carbon atoms. Now, if you observe in this one, now I'm expanding this molecule. One carbon has 2 hydrogen atoms. Next, this carbon has 1 double bond. One more carbon, double bond. This one, C, H, H. This is the expand form of the alene molecule. So in these alene molecule, first identify the number of bond pairs. That means sigma bond only. Okay, na? Only sigma bond. So that sigma bond identify here. 1, 2, here 3. This is the pi bond. Again here also this one is a pi bond. It is sigma, sigma, sigma bond. So these are the sigma and pi bonds only. So in this sigma and pi bonds majorly, how to identify that? Okay, that identification also in this 1, 2, 3. 3 bonds means the hybridization of this carbon is sp2. Now coming to this carbon middle. In this middle carbon, 2 sigma bonds only present. The hybridization of this carbon is sp. 2 bond pairs only consider. Now here number of sigma bonds 1, 2, 3. 3 means this hybridization is again sp2. So these kind of molecules are majorly sp2, sp, sp2 combination only present. sp2, sp, sp2 combination. So now this one hybridization in two double bonds adjacently present. Those are called alene molecules. Okay, those are called alene molecules only. Next, another example I will explain. Another that molecule is vinyl acetylene. Next example is vinyl acetylene molecule. So vinyl acetylene means that compound representation CH2 double bond CH. Acetylene means C triple bond CH. So this one is called vinyl acetylene molecule. So in this vinyl acetylene molecule, here also one double bond, triple bond, but this kind of molecule name is called vinyl acetylene molecule. Generally, if you expand this molecule, H, C, H, double bond, C, H, single bond, C, triple bond, C, H. So this one is the molecule. Okay, ma. This one is the molecule. In this molecule, first identify the number of sigma bonds here. 1, 2, 3. The remaining it is pi bond. Next here also hydrogen sigma, sigma. Here one only consider sigma, the remaining two are the pi bonds. Here also sigma. Now here total sigma bonds surrounding on this carbon is 3. So this hybridization is sp2. Next this carbon 1, 2, 3. Again this carbon hybridization also sp2. But this carbon 1 sigma, here 1 sigma. Totally 2 only. So the hybridization is sp hybridization. And one more, another carbon also 2 sigma bonds. This one also sp hybridized carbon. So totally the combination in this given vinyl acetylene molecule is sp2 sp combination. Right? sp2 sp combination only. Then next another molecule divinyl acetylene. Divinyl acetylene molecule. Now the structural, how many vinyl groups? 2 vinyl groups. CH2 double bond, CH, C triple bond, C, CH double bond, CH2. This one is called diacetylene. Divinyl acetylene molecule. So in this divinyl acetylene, on this part it is vinyl. This one also vinyl. So the middle carbon it is triple bond, it is acetylene. So divinyl acetylene molecule. Here number of bond pairs identify 2 plus 1 3. 3 means it is sp2 hybridized. Again here 1 2 3. 1 hydrogen. This is the another bond 2. This is the 1 sigma. Totally 3. So it is also sp2. Now this carbon here 1 sigma, here 1 sigma. The remaining 2 pi bonds. So this carbon is sp hybridized. What about this one again? sp hybridized. Same type of these two. Again this carbon sp2. This carbon also sp2. So we can easily identify the hybridization of the central atom given in a molecules. Okay, central atom given in a molecules. The next, suppose my ether given, diethyl ether. Another example is diethyl ether. Diethyl ether means number of carbons 2 like this. It is CH3, which is attached to one oxygen, one more carbon. Here also CH3, three hydrogens attached to one carbon. Now this is called only ether, diethyl ether. This oxygen has two lone pair of electrons. Two lone pair of electrons. So identify the hybridization for this kind of molecule. So hybridization is depends on the number of bond pairs and lone pairs. So now it is a sigma, hydrogen sigma, here also sigma, this is the sigma. So this carbon hybridization is sp3. Next, this carbon ma 1, 2, 3, 4. Again, this carbon also sp3 hybridized carbon. But the two carbon atoms ma attached to one oxygen. Now this one has, it is a one lone pair. This is the another lone pair. So for oxygen atom, two sigma bonds means two bond pairs. Plus, how many lone pairs ma? Two lone pairs also present. Bond pairs plus lone pairs sum is totally 4 means oxygen hybridization also sp3. So this is the hybridization of which molecule? Given diethyl ether. If one instead of a carbon hydrogens ma another elements also present, we can identify the hybridization of that elements. So majorly nitrogen, oxygen, sulfur. So these kind of molecules only mostly present. Mostly for that kind of molecules we can easily identify the hybridization. In this one more example ma, suppose sometimes they will ask formaldehyde. What is the hybridization of carbon present in the formaldehyde? So the general form is H C double bond O H. This one is the formaldehyde structure. In this formaldehyde structure, so generally identify number of bond pairs and lone pairs. It is a central carbon. This is the sigma. This is the sigma. Here carbon attached to double bond oxygen. One is a sigma, another one is a pi. So central atom carbon is present. So we can write only hybridization for that carbon. Then how to write my number of sigma bonds count? 1, 2, 3. 3 means ma sp, 2 is the hybridization. So this one is the hybridization for which molecule? Formaldehyde. Next, one more example. Suppose sometimes they will ask cyclic rings also like this. Cyclic rings. The name of this one is called cyclohexane. Cyclohexane. For cyclohexane molecules, so we can write here a number of carbon atoms attached to the bonds also. Here are two hydrogens. Here also two hydrogens. Two. Identify each carbon has four bonds on the surrounding. Each carbon surrounded by four bonds. So four bonds means it is always sp3 hybridized molecule. Totally all carbons sp3 hybridized only. So that complete molecule is sp3. Same as like one more example. This one more, it is one double bond. Here also double bond. Here also double bond. Alternative double bonds present in this. So alternative double bonds present means how to identify? Here this carbon has one hydrogen. This one also has one hydrogen. Here also. Now six carbon atoms has here six hydrogen atoms. Now if you observe each and every hydrogen atom, all are the sigma bonds. This is the central atom carbon. It is one sigma. This is another sigma. Hydrogen is sigma. Totally three. One carbon has three sigma bonds. Now each and every carbon hybridized atoms. Carbon has sp2. So total overall molecule is also sp2 hybridized molecule. Then next, same kind of another one. Means it is not a cyclic ring, just open chain only. CH2 double bond CH1 free radical given. That means it is a vinyl group only, but with free radical. Vinyl free radical. Now this carbon has two hydrogens, two bond pairs. It is a one sigma, one pi bond. So totally three. So this is the sp2 hybridized carbon. This one ma, one is the sigma, one is the bond pair. Here two bond pairs only, one single electron is present. It is no need to consider the lone pair. So that's why here totally the hybridization of this carbon is sp. One is the hydrogen bond, another one is the sigma bond with the carbon, totally two. So it is the sp. Okay ma. So like this we can identify the hybridization few molecules. And if any heteroatom which is attached to the aromatic rings, that time how to identify the hybridization. So that one also we will discuss now. So majorly we know that if a nitrogen atom attached to the 5-membered ring with the alternative double bonds. So now this is the one molecule. This is the nitrogen atom. Like this, it has one hydrogen lone pair with alternative double bonds. This one. So with the alternative double bonds means this carbon has one hydrogen atom. This one also one hydrogen. Here also one hydrogen atom. Here also one hydrogen atom. So identify this is the middle carbon. It is sigma bond 1, 2, 3. So 3 sigma bonds means it is sp2. Here also same 3 bonds only present. It is a pi bond. It is also pi bond. So this carbon also sp2. What about this carbon? Again sp2. This one also sp2 carbons. All are the sp2 hybridized carbon atom. But what about the nitrogen? So nitrogen has here 3 bond pairs, one lone pair. It is sp3 na? No, it is not sp3. So overall this molecule is also sp2 hybridized molecule. How to identify that hybridization here? This lone pair, it is involving in the delocalization with this. If it is involving in the delocalization, then this nitrogen here get the one double bond. Consider only one bond sigma. Okay, out of the two, one is sigma. The remaining two bonds are single bonds. So it is also sp2. If there is no lone pair, means it is not involving in the hybridization, but it is involving in the hybridization. Sorry, if it is involving in the delocalization, now this nitrogen also sp2. Total overall this molecule is a sp2 hybridized molecule. So this is very very important, this kind of molecule also. And another molecule same like one more also. Six membered ring with alternative double bonds. Here this one has one lone pair. So the lone pair of electron present on the given compound. Here also this one has one hydrogen. Here this one if you identify the remaining all carbon atoms are the sp2 hybridized carbon atom. Nitrogen also identify one sigma, another sigma, one lone pair. Totally three only na, two bond pairs plus one lone pair. Here this lone pair not involving in the resonance, okay, or conjugation. So that's why here overall this molecule also sp2 hybridized molecule. So this kind of hybridization is also important. We can identify that hybridization of the molecules. So one more, if not alternatively present, the double bonds are not alternatively present. So how to identify that? Here this one is the hydrogen. Here only one double bond. For this kind of molecules, how to identify that hybridization? Well, this one has one hydrogen. This one also has one hydrogen. Here two hydrogen atoms. Here also two hydrogen atoms like this. Now here one lone pair of electron. This carbon has 1, 2, 3. So sp2. This carbon also sp2. Here this carbon has 4 bonds only now. Now this hybridization is sp3. What about this one? sp3 hybridization. Now nitrogen here there is no conjugation with adjacent. There is no conjugation alternatively. Consider here totally 3 bond pairs plus 1 lone pair. 4. That means sp3. Here nitrogen is sp3 hybridized atom. Okay ma? So this one identify the hybridization of the given molecules. So we can easily identify the hybridization for that kind of molecules. If instead of that one was sulfur atom given, or if any other kind of molecules, suppose now I'm taking here one more CH2 double bond CHO CH3. This one now. This one is called, it is ether molecule, but this part is vinyl. Vinyl methyl ether. Okay, ma? The name of this one is called vinyl methyl ether. So in this vinyl methyl ether, so how to write the name? The number of the name of this one, hybridization. Carbon here, sp2 hybridized carbon. Here also this one is sp2 hybridized. This oxygen has two lone pairs. This carbon is sp3. What about this oxygen? It is also sp3. So we can write hybridization of the given molecules. So by using this, we can easily identify the hybridization of the molecules. So in this, after identification of the hybridization in a given molecules, how to calculate the hybrid orbitals, unhybrid orbitals, number of sigma bonds, number of pi bonds. So these conditions also important. Okay, ma? So the next here, hybrid orbitals.